Okay, in this video we are doing problem set 51 from Calc AB. The problems and a playlist are in the description below, and let's see what the problems look like. Given f of x is e to the 2x, g of x has the values in the table above, we want to find d dx, so the derivative of f times g of x at x equals 2. So that's just going to be the product rule, so I'm going to write down the product rule. First, derivative of the second plus second derivative of the first. The derivative of e to the 2x is 2e to the 2x because of the chain rule. Now we have to evaluate this at x equals 2, which means there's a step you should do, I believe, where you actually show plugging in 2. So that'll be e to the fourth g prime of 2 plus g of 2 times 2e to the fourth. I like to show that so that I can backtrack when I get it wrong. G prime of 2 is 3 and g of 2 is negative 2. So we plug those in. So we get this times 3 and then negative 2 times 2e to the fourth. And then when we simplify that, I think we get negative e to the fourth. If I get anything wrong, let us all know in the comments, I guess, because I kind of blew through this when I was writing it down. So hopefully it went right, but we'll see. All right, find the derivative of f over g, or f divided by g. So that's going to be the quotient rule. So I'm going to write down the quotient rule. Bottom, derivative of the top, minus top, derivative of the bottom, over the bottom squared. We have to evaluate this at 4. I do think you should show the next step where you're subbing in 4, so g of 4, 2e to the 8th minus e to the 8th, g prime of 4 over g of 4 squared. Let's look at 4. G of 4 is 5, g prime of 4 is 4. So we're going to plug those values in. And then once we've done that, we'll get 10e to the 8th minus 4e to the 8th is 6e to the 8th. So I think we get 6e to the 8th all over 25. All right, and then we have one more part here, right? The equation of the line tangent to h of x equals f times g at x equals 4. So same derivative as we had before, right? H of x is the same as the function that was in a, but we're evaluating at 4 this time. So you can kind of just steal the derivative, right? It's e to the 2x g prime plus g times 2e to the 2x. And then we want to evaluate at 4. So I'm going to just jump right to that. So h prime of 4, also I ran out of space on this, so I'm just cramming it in kind of wherever it fits. E to the 8th, g prime of 4 plus g of 4, 2e to the 8th. At 4, we knew g was 5 and g prime is 4, so we're going to sub those in. So that's going to give us 4e to the 8th plus 2 times 5 is 10e to the 8th, so 14e to the 8th. We also need to know the value of the function, so we need to find h of... what are we doing here? We're finding h of 4, which is f times g. So e to the 8th times g of 4. G of 4 is 5, so 5e to the 8th. And then we'll write our tangent line. So our tangent line is going to be in point slope form. Y minus 5e to the 8th equals 14e to the 8th, which is incredibly steep, the quantity x minus 4. So that's our first problem. Let's look at the next one. So on this one, I had to find a bunch of areas that I did not want to find. So hopefully we get this right, but we'll see. Use a graph of v of t shown above to answer the questions that follow. Where is the speed decreasing and why? So speed will be decreasing when velocity is positive and velocity is decreasing, or velocity is negative and velocity is increasing. So that's what we're looking for. So these are the regions where v of t is greater than 0 and decreasing, or v of t is less than 0 and increasing. We just have to say those. So I'm going to say speed is decreasing on 0 to 1.5, 2.5 to 4, and 5 to 6.5. My reason is going to be exactly what I said. So I'll say v of t is greater than 0 and v of t is decreasing, or v of t is less than 0 and v of t is increasing. Those are the two things that will lead to speed decreasing. All right. B, find the displacement on 0 to 4. All right, so we got to find a lot of areas here. What I'm going to do is erase this. All right, so first thing I'm going to do is this triangle below the x-axis, and that has a base of 1.5, a height of negative 1.5. So you multiply those, you get negative 2.25, and divide that by 2, negative 1.125. Then we have to find the area from what to what? From 1.5 to 4, I guess. So I kind of divided this up this way. So I got 1.25 for that, I guess it's a trapezoid, and then 0.5 for both of the triangles. You can find the area however you want. I basically count boxes. on these problems. So overall, that is 2.25. So 2.25 to the right, 1.125 to the left. And then, I think I did this wrong. Displacement. I was only supposed to go from 0 to 4. Oh, man. I went all the way to, what did I do? 2.12. I don't know what I did. So I kept going here. I'm not sure what question I think I'm answering. So let's see. I found displacement. I found displacement all the way to 7, and that was wrong. So I didn't want to do that. So I'm going to write an answer here. It's wrong, and then I'm going to try to fix it. So that negative 1.125 we want. That positive 2.25 we want. This negative 2.125 we do not want. So let me jump so where I like add them together, and then I'm going to delete all of that. So this would be our answer, I think. So I think our answer is actually 1.125. So let me do that. 1.12, that's an equal sign. It looks like an approximately equal to sign, but it is not. All right, I think that is our answer. All right, and then we have one more part. When does the particle turn around? The particle turns around where the velocity changes sign, right? So that's gonna happen at 1.5, at 4, and at 6.5. So let's write that down. Particle turns at 1.5, t equals 4, t equals 6.5, because velocity changes sign there. I'm so annoyed that I didn't even need to find all those other regions because they were like not fun to find the area of. It's fine. But anyway, make sure you really read the questions, which I apparently didn't do. That's the end of this problem set. I hope you found this helpful, and good luck.